All right, this video is to remind you how to factor. So remember that factoring is essentially just unmultiplying our polynomials. In order to factor, if there's no coefficient on the x squared term, that's all this video will talk about. First, you find two numbers that multiply to the constant and add to the coefficient on the x term. These two numbers go in the parentheses, getting added or subtracted with the x's, and we call these sets of parentheses the factors. So to factor x squared plus 38 plus 72, I need two numbers that multiply to 72 and add to 38. Well, numbers that multiply to 72, I could do 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, or 8 times 9. Well, which of those adds to 38? 2 and 36. So my answer would be two sets of parentheses. The only way to break apart an x squared is an x and an x. It's a positive 2 and a positive 36, so I write plus 2 plus 36. I can flip-flop those around and I can write x plus 36 times x plus 2. That's totally fine, same exact answer. So for our second one, x squared minus 9x plus 14, we need two numbers that multiply to 14. Well, my options are 1 times 14 or 2 times 7. Those are my only options. Well, what adds to make negative 9? Well, 2 and 7 make 9. If I make them both negatives, they multiply to a positive and add to a negative. So I have x minus 2 times x minus 7. Ooh, close my parentheses. For x squared plus 10x minus 20, I need to look for things that multiply to 20. I have 1 times 20, 2 times 10, or 4 times 5. Well, none of those would make a 10. Whether I'm adding or subtracting those numbers together, there's no way to make a 10. This is an example of one that can't be factored. Not every trinomial can be factored, and that is very important for us to realize. Let's go back to some that can be, though. X squared minus 7x minus 30. Numbers that multiply to 30 are 1 times 30, 2 times 15, 3 times 10, or 5 times 6. To make negative 7, I know to make negative 30, I have to multiply a positive and a negative, which means one of the numbers is going to have to be a negative in here. And to make negative 7, oh, look at that. Negative 10 plus 3 would make negative 7. So I take x minus 10 times x plus 3. Negative 10 and positive 3. These are some special case problems. So, two numbers that multiply to 25 and add to 10. Well, my options are 1 times 25 or 5 times 5. Well, 5 and 5 make 10. So I have x plus 5 times x plus 5. This is a special case because I could shorten this to x plus 5 squared if I wanted to. Second one, x squared minus 49. Well, where's the x term? Remember that there is secretly a 0x hiding in there, if that helps me. So I need two numbers that multiply to negative 49, which means one of them has to be positive and one negative. Well, I can do 1 times 49 or 7 times 7. One of them has to be negative and they have to add to 0. Well, that means a positive 7 and a negative 7. So x plus 7, x minus 7. And there's no logical reason to it, but this is my favorite pattern. This is called a difference of squares. X squared is a perfect square, 49 is a perfect square. I'm subtracting them. It'll always factor like this, x plus something, x minus something. All right, for x squared minus 15x plus 56, I need two numbers that multiply to positive 56. Well, my options are 1 times 56, 2 times 28. Let's see, 3 doesn't go into 56. 4 times 14, 7 times 8. I want to make a negative 15. Well, since I have to multiply to positive 56, I know that they're either both positive or both negative. To add to negative 15, they must both be negative. So 7 and 8 makes 15, so I call it x minus 7 times x minus 8. The next piece of this is to always, always, always check for a GCF first. Remember that GCF stands for greatest common factor. We are always going to take a GCF out first if we can. So for 3r squared minus 15r plus 18, well, I noticed that 3, 15, and 18 can all be divided by 3. So I take a 3 out front. And now I'm dividing each of my terms by 3, which leaves me with r squared minus 5r plus 6. Now I need to factor the rest of the way. My 3 hangs out along for the ride. The only way to break apart r squared is r and r. Now I need two numbers that multiply to positive 6 and add to negative 5. Those would be negative 2 and negative 3. For 4x squared minus 4, I start with my GCF. Well, they both have a 4, so I'm going to take a 4 out. Leaves me with x squared minus 1. Remember, anytime you don't have a middle term of x, there's secretly a 0x hiding in there. So I need two numbers that multiply to negative 1 and add to 0. My 4 comes along for the ride. The only way to break apart x squared is x and x. Well, the only way to multiply to 1 is 1 and 1. And to get them to add to 0, we need positive 1 and negative 1. For 2n squared minus 4n minus 6, start with our GCF. The biggest thing I can take out of all of them is a 2. If I take a 2 out of everything, I'm left with n squared minus 2n minus 3. Now my 2 comes along for the ride. I make my 2 sets of parentheses. The only way to break apart n squared is n and n. Two numbers that multiply to negative 3 and add to negative 2 are negative 3 and positive 1. And finally, 6x squared minus 84x plus 294. I can take a 6 out of all of those terms, leaving me x squared minus 14x plus 49. All right, now my 6 comes along for the ride. Make my 2 sets of parentheses. The only way to break apart x squared is x and x. Two numbers that multiply to 49 and add to negative 14 are negative 7 and negative 7. All right, for our next example, x to the 4th power minus 36x squared. Your GCF can involve x's. I can take an x squared out of both of these terms. If I take x squared out of x to the 4th power, I'm left with x squared. If I take x squared out of 36x squared, I'm left with 36. So my x squared is coming along for the ride now. The only way to break apart x squared is x and x. Two numbers that multiply to negative 36 and add to that 0 that's in the middle there are positive 6 and negative 6. And finally, for this last one, 7x cubed plus 49x squared plus 42x. Well, I can take a 7 out of everything, but I also see that they all have an x. So I'm going to take out 7x. If I take 7x out of 7x cubed, that leaves x squared. If I take 7x out of 49x squared, I get 7x. If I take 7x out of 42x, I get 6. So now my 7x comes along for the ride. Make my 2 sets of parentheses. The only way to break apart x squared is x and x. Two numbers that multiply to 6 and add to 7 are positive 6 and positive 1.